Question 1. Figure 1 shows a large wind farm off the coast of the UK. So here's a diagram showing us the wind turbines responsible for generating electricity at the coast of UK. It says the mean power output of the wind farm is 969 MW. Now remember, this capital M stands for mega, and mega is a million. I can say this is basically P is equal to 696 times 10 to the power of 6, and now this value has been transformed into watts. So I've done a unit conversion. This is enough power for 580,000 ohms. It says calculate the mean power needed for 1 ohm. To find the value of power needed for 1 ohm, all you have to do is you'll divide this value 696 times 10 to the power of 6 by the total number of houses, which is 580,000, and the answer will be 1200 watts. Next part says on one day the demand for electricity in the UK was 34,000 megawatts. Now if you look at the value here, this is 696 megawatts, this is 34,000 megawatts. So this is much more than the amount of electricity that wind farm can produce. So it suggests two reasons why wind power was not able to meet this demand. So basically when it says was not able to, you just have to discuss limitations. Limitations of wind turbines. So first one we can think about is we can say they are unreliable. Option 1. The second bit that we can think about is that we can say not enough wind. We can also talk about the fact that they do not operate if the wind is too slow or the wind is too fast. See, do not operate if wind is too slow or fast. We can also recall that they do not produce a lot of electricity because they have very low efficiency. We can say do not produce a lot of electricity. Next part says some of the energy from the wind used to rotate a wind turbine is wasted. Now remember, this wasted energy always goes into surrounding as thermal energy. It says an engineer oils the mechanical parts of a wind turbine. Explain how oiling would affect the efficiency of the wind turbine. So I'm going to recall the formula for efficiency. Formula is efficiency equals useful over input. Now remember, we can't do anything to the input, so input is fixed. What will happen to the useful part? I can say this will increase because less friction between moving parts now. And if there's less friction, and that means that you'll have bigger value for useful. Now my denominator did not change, but my numerator has now got a bigger value. So what will happen to my efficiency? I can say therefore my efficiency will increase, and this will get you full 3 marks in your exam. Next question. In most homes in the UK there are many different electrical devices. Explain why people should be encouraged to use energy efficient electrical devices. Now if you use efficient electrical devices, then this means you can say less energy will be required. So if less energy will be required, I can then say our demand will go down. It will decrease. Now you have to remember, most of our electricity is being produced by burning fossil fuels. So if there is less demand for the electricity, you can say environmental impact will reduce. In bracket, I can write down due to less use of fossil